All right, hey class, so we're doing a recap of the November 20th physics review. You'll notice the answer key is already posted, as is a video from another YouTuber physics teacher. But what I want to do is go over the answers to this in case you're not following where my word came from. So let's switch over to the dot cam and we will see the me going through these questions, okay? So we're gonna be going through these one at a time. Like I said, we already have the answers, but maybe you're confused by some of the points. So let's take a look at number one, okay? All right, so number one, let's see if we can come in here a little bit closer. All right, so we are looking at 3 meters and it takes 5 seconds for it to go up and return to its original position in 5 seconds. Okay. All right. Which means I'm going to use 2.5 seconds to go the 3 meters up. Okay. All right. And the first question is draw and label a velocity time graph. Well, what I expect to happen here, if I have velocity and time, and let's call this 0. Okay. Then what I expect is it's going to start off going fast. It is going to hit the top of the ramp and then it is going to come down the exact same speed. So I expect this to be a fairly linear graph, okay? And we'll in fact be able to find this velocity if we want to. But the real question is finding the acceleration, okay? So we want acceleration. So in order to do that, we can do it one of 2 ways. We can do change in velocity over change in time, or we can do a derivation or solve for this one. Okay. My tendency is always, if I'm going to do a guess and check, this is always going to be my first guess. Okay. So the question is, do we have enough data points to get this done? So let's start listing our data here. So we know just the time for it to go up was 2.5. We know the distance is 3 meters. We know that the velocity at the very top was 0. Okay. Now, so we knew this point. We don't know these other points. So remember, acceleration is just the slope of this line, okay? It is just rise over run, okay? So if we know this velocity, we can find this acceleration, which is going to be the same for this acceleration, okay? So if this is the velocity here, it goes down 3 meters in 2.5 seconds. Okay, so it started, went down 3 meters, it started at 0, it started at 0 meters per second, and 2.5 seconds. And this is what we're looking for, right? We want to find acceleration. And it did that in 2.5 seconds squared. Okay, so 0 times 0, or 0 plus 0, all those are going to cancel out. So we're going to get 3 equals 1/2 a 2.5 squared. Okay, so we can take our 3 over 1/2. And that is going to equal our acceleration. Okay, you plug that into a calculator and you should get 0.96, okay? All right, now, let's do a little aside here since this is a review. Let's think about what are these 2 points, okay? Well, we know it went down 3 meters in 2.5 seconds. So we can say it went down 3 meters in 2.5 seconds, right? I'm doing velocity average equals change in distance over change in time, okay? So if that is the equation we're doing, then that gives us a velocity of 1.2 meters per second average, okay? And my V final is going to be 2 times my V average, which is 2.4 meters per second, which means we could then put those in here, by the way, if we want to. Okay. Now, why did I do all that? So now we have the average velocity, the final velocity. We have the velocity here. So now we could do this one, change in velocity over change in time. So it changed 2.4 meters per second over 2.5 seconds. And what do we get for an answer? 0.96 meters per second squared. So there's 2 different ways to approach this. We could do find the average velocity, find the final velocity, find your change in velocity over change in time, and get the same number because we're still finding the slope of this graph. Okay, that was number 1. Number 2, we're looking at this one right here. Randall throws the bowling ball. We're giving a distance. We're not given a time. Okay, so let's start with our variables. We know okay, so remember, there's always one question I always go to, an equation. Okay, this is always a good guess, but it has time and it has acceleration. Too many unknowns for one equation. So we need a different equation that has fewer unknowns. Okay, this has acceleration. It does not have time, so we can skip that. Okay, so now we can do 8. Okay, now we can solve for A, and our distance is 1.5 meters. Okay, 8 times 8 is 64. 0 times 0 is 0. We're on both sides, we're going to divide by 2 times 1.5 meters. Okay, and when we do all of that, our answer should be 21.3. Okay, so that was number 2. Okay, all right, now let's go on here. I think we can put number 3 on here. No, I don't think we will. All right, let's try this way. Number 3. Okay, number 3 was the launching something off of the cliff here. Okay, so here we have, okay, and v of x equals 8 meters per second. Okay, remember this is a parabolic motion, it is not a triangle. Okay, so and we're trying to solve for d of x. Okay, so let's list some of our constants we always know here. Okay, and Okay, so that is just some of the constants we are just, that's embedded in the question. So we're going to take that and go with it. Okay, by the way, hint, we might be seeing some questions on Mars on our DEX test. So I'll give you a different acceleration there. Okay, so we want to be able to find distance of the x. That is our goal. Okay. So ideally, we could just use this equation. Okay, so we know this is 0. We know this is 0. We know this number, right? But we do not know time. So we're going to have to back it up here, and we're going to have to find time. Okay, so again, same equation, different direction. Okay, now we know some of these numbers. We know it ends at 0. We know it started at 3 meters. We know it started at 0 meters per second. Okay, we're looking for time. We know this is negative 9.8. And we're looking for time. Okay, so this guy went to 0 again. So we're going to get negative 3 equals 1/2 negative 9.8 t squared. Okay, so t is going to equal square root of 3 over 1/2 0.8. Okay, and if we do all of that, we should get our time is about 0.78 seconds. Okay, now we can plug that in here. We have our velocity and we have our time. Okay, also this becomes a much simpler equation, and we get, okay, so when I'm grading the papers on the test, I am going to be looking for the diagram, the setup, the governing equations, and the answer. Okay, so don't just skip to the answer. You're not going to get as many points. All right, moving on here. Number 4. Number 4 is a nice, simple one here, so I'm going to keep things moving along. Okay, so number 4, what we see is a very simple diagram. We have our bowling ball. Okay, it is moving in this direction, but the force from the wall is pushing out. Okay, so, and when it does that, we have an acceleration of negative 75 meters per second squared and a mass of 4 kilograms. Okay, so it is really slamming into the wall, and it's fairly heavy bowling ball. As bowling balls go, not too heavy though. Okay, so this is my diagram. These are my givens, governing equation. Okay, and then we should just be able to plug this right in here. Okay, so this is the stopping force for the bowling ball when it hits the wall. Okay, all right, so that one went a little bit faster. Now we can look at our last page here. Let me switch over. So now we're looking at this one. It is set up in a very specific order that helps you structure your work. I could just ask for acceleration, and you'd have to find most of these anyways. And you're going to use these two facts in the next question, which is also part of the reason why I asked them. Okay, so at this point, we've determined that bowling balls are not, in fact, round, they are square. Okay, they're flat bowling ball society. Okay, so here we see 30 newtons equals force of gravity. Okay, 30 newtons equals our force normal. 50 newtons equals our force applied, and 10 newtons equals our force of friction. Okay, remember, these two are not guaranteed to always be equal and opposite. Okay, if you step into a snowbank and start sinking, then this number is going to be bigger than that one. If you have a rope tied to this and you are pulling at an angle, then you're going to be taking off and you're going to reduce this number. Okay, if you're sitting on a ramp, then all sorts of things change. So do not assume that these are always equal and opposite. This is a very specific situation of it sitting on a horizontal surface and only moving in the x direction. Okay, all right. So what we see here is our first question looking for mass. Okay, well, we can use force of gravity equals mass times g. So mass is going to equal force of gravity over g equals 30 newtons or 9.8. Okay, and that should get you just over 3. Okay, that's going to be something we're going to use in the next question. So we're going to hold on to that. It's going to be used probably twice more here. Okay, next question was, how do we find mu? Okay, coefficient of friction. Well, luckily we only have one equation that equals that. Okay, which means we can use force of friction over force normal. Okay, again, if you have these all lined up in your homework, then when it comes time for the test, you're just going to be changing a few numbers. Okay, so here we have force of friction and force normal. Okay, no units on a coefficient. All right, next up are sum of our forces. Okay, so this is going to be our force normal plus our force of gravity. Okay, sum of our forces in x is going to be our force applied plus our force of friction equals okay, don't be afraid to use a calculator on the test. Even for the simple ones, we don't want to see any mental errors because you're so focused on so many other things. Okay, by the way, if this was a non-zero number, then we would have to do our force in the y and our force in the x. And we'd have to resolve that here, okay? And we'd have to do a squared plus b squared equals c squared to get this, okay? It's 0, so we already know our forces is 40 newtons, okay? All right, so now we can come down to our final question, which is our acceleration. Okay, well, acceleration, okay, we don't have any acceleration in the y, so we're only going to do x. So we're going to get f of x over m. Okay, so that's going to be 40 newtons over 3.06 kilograms. And that should be, come on, please, 13 meters per second squared. Okay. All right, one more to go here. Okay, and that is we're going to take these two numbers and we're going to use them in the next question. Same bowling ball, same surface, okay? It's just, now it's going to be at an angle, okay? So we're going to take those two numbers and do number 6 here. All right, by the way, this is number 5, I suppose, right? Okay, number 6, we're going to use m equals 3.06, mu equals 0.3. Okay, those are our givens. And then they gave us a little slope here. I was imagining it as a, I can't talk and write at the same time. I was imagining it as a cornhole ramp, okay? And then this flat earthed bowling ball comes up and starts acting on it, okay? So we're gonna have the force of gravity, and we're gonna have force normal, and we're gonna have the force of friction. Force of friction might be this way or that way. It's whatever way opposes motion, but we know it's going to be acting in the plane of the surface, parallel to the surface. And we know the force of friction is going to be perpendicular to the surface. The one that is neither one of those is the force of gravity. So let's pull out the force of gravity very quickly and resolve those forces. Okay, so we're going to have an F of the y, and we're going to have f x. Okay, these are in the same direction, maybe not equal. As long as this is not a snowbank or it's not on a spring or anything like that, this and this is going to end up being equal and opposite. Okay, so now we can start looking forward to finding these points here. So we remember our final goal is to find my force of friction and my force normal. Okay, that's where I'm trying to get to. Okay, so let's figure out what these are just in case we need to know these things. Okay, so here's my angle, same angle as that. So now I am adjacent. Okay, so I'm going to do force of gravity adjacent is cosine of theta. So that is going to be, remember, we still have the same force of gravity. So this is going to be, force of gravity is 30 newtons. So I'm going to do 30 newtons times the cosine of 20 degrees. So that is going to be 28.2 newtons. Okay, so that was my force in the y. My force in the x is equal to force of gravity. Now I'm opposite of that. Okay, so now we have our 30 newtons times the sine 20 degrees. Make sure your calculator is in degrees. Make sure you put it in right. I had a typo the first time I did this. So I'm actually going to flip over to find a better number. By the way, I don't even know if I'm going to use all these numbers. I'm just banking any facts I have. Okay, so this should be about 10.3 newtons. Okay, so I'm not guaranteeing the most efficient motion. I'm guaranteeing I have this great big pool of facts I can now use to do this. Okay, so what are we going to do? We're going to do same thing always. We're going to take these and then let's start looking for the sums of the forces. Okay, in the y, that's going to be 0. All right, so that means that my force normal and my force in the y has to add up to be 0. So remember I was saying those can be equal and opposite. This is y. Okay, so if this was 28.2 newtons, this is going to be equal and opposite to 28.2. Okay. All right, now sum of my forces in the X. This is not 0. And in fact, nowhere in the question does it tell us where it is. So this may not be the best path forward. But we know force normal and we know coefficients. So we can take a different path for that. Okay, so now we can take a look at mu was 0.3 and we can multiply that by our force normal. Okay, and when we do that, we get about 9.38 newtons. Okay, so that is the final answer. Okay, one thing I asked students in class was, if this is 10.3 and this is 9.3, 9.38, then what's happening to this? Okay, we take the bowling ball, it slides up the ramp, friction will oppose motion, it'll slow down and come to a stop. When it gets to its stopping point, does it remain at rest or does it keep moving? Okay, well, the answer is this number is bigger. Okay, that one was bigger than this one. So it will start to slide back down the ramp, which is kind of, that's what I was thinking about cornholes, because that's kind of the nightmare scenario. You got the bag up on the ramp and then it just slide back down. Okay, it'd be, you ever want to be mean to someone playing that game, somehow like decrease the coefficient of friction so that it just slides back down, or prop it up higher. That would also be trickier. Okay, so that takes us through all of the questions. One thing someone asked me at the end of class was about the lab. Okay, the lab is similar to this one in the triangle, but we see one different change here. Let's see if I can pull the paper. Okay, so in this scenario, we have, looks a lot like the cornhole, the bowling ball question. But as you were going through the lab, you started here and you went up and up and up. And at some point, this force in the X exceeded the force of friction and went from sitting still to moving. Okay, that breaking point where this one equals that one, that is what we're trying to measure, that angle. And for that one specific moment, our f of x equals the force of friction, and always our force normal equals our force in the y. Okay, as long as we're not breaking the board. Okay, so if this always equals this, and at that one point in motion, this equals that, then we can take our two legs of our triangle and plug in mass times gravity times the sine of theta, and mass times gravity times the cosine of theta. Excuse me, that's backwards. Okay, and sine over cosine is all, so these masses cancel out. And sine over cosine is the same thing as tangent. And so for this one brief moment, the coefficient of friction is going to be the same as the tangent. But that is only true at one specific moment. Okay, so keep that in mind as you work through the lab and the test. This is only true for one point. Okay, so with that, have a good day and a good weekend, and good luck on your test.